Do you just write like HHH and then like HHT and like that?
Yeah, let me see. 3 fair coins are tossed. All the possible outcomes, yep. And then how about question B?
I don't know how to do that.
Okay. Question B. A random variable is defined as the number of heads with 3 coin tosses. What? So let's say X is the number of times it lands on heads, and then the probability that this particular one lands on that. I'll elaborate on that in a minute. What are the possibilities for this one? What's a possible number of times it can land on heads?
3.
Are there any other possibilities? That's the maximum.
Pardon, sorry?
So, is it definitely going to land on heads 3 times?
No.
So, how many times?
Might be twice or once or 0.
True. And so the possibilities are 0, or once, or twice, or thrice, 3 times. What's the probability it lands on heads 0 times? That means it lands on tails 4 times.
4.
Probability.
One out of 6.
So you flip a coin. Probability it lands on tails.
The first.
Flip a coin.
Yeah.
Probability it lands on tails.
50%.
Sure. I'm going to call it 0.5. Probability. You flip a coin. Probability the second coin lands on tails.
Half.
And so, what is the probability that both coins land on tails?
0.5 times 0.5.
Yep. And you now flip a third coin. What is the probability that all 3 coins land on tails?
1 over 8.
Yep. That is 1 over 8. Okay. Probability 1 coin lands on heads.
Just 0.5.
You flip 3 coins.
So if it's once on heads, then you do 0.5 times.
So I believe I've done it here. So heads, 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 tails, heads, tails, heads, heads, tails, 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 head, head, T, H, T, 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 H, T, T, T. Yes. How many have exactly 1 heads?
3.
3 out of
8.
2 heads.
3 as well.
Out of 8. Probability of getting all 3 heads?
1/8.
What did you all add up to?
1.
Yes. And so that is your probability distribution table. Yes, any questions about that?
No.
Let us now look at this probability mass function. Fancy term. So this is our probability table. Number of heads is x, and then the probability that this particular x is 0 or 1 or 2 or 3. Probability x equals x. So this is the probability mass distribution function. Probability mass function. 1/8, 3/8, and 0 for x equals 0 and 3, x equals 1 and 2, and there's no other possibility. There you go. Any questions about this probability mass function?
Do you have to write 0 if there's not any possibility for it?
I'm gonna say yes. Otherwise 0. That's my answer. Right, exam question. Any idea about this?
And please can you move it down a little bit? Thank you. So is it the probability that x is 2 and 3?
Well done.
So you write the symbol and then a half
No.
x equals
Just what's the probability x is 2 or 3?
a half and 1/8.
One mark question. You've got 0 marks.
When
A half and 1/8 is?
do we add them?
We sure do.
So 5/8.
Yes. Either or, add, both and multiply. So either 2 or 3, your odds are increasing, and so you're adding them. B.
So the probability of 0 and 1, so 1/8 plus 1/4, which gives us 3/8.
And C.
um 0.
Yep. Any questions there?
No.
Don't overthink. 5/8, 3/8, 0. Okay. Before you cheat this, man, every single date. Okay, how about this one?
What does it mean, the name of the distribution?
You haven't seen it yet. If all of the probabilities are the same, so let's say probability of rolling something on a dice like 0, 1, 2, 3, 4, 5, 6, it would be 1 out of 6, 1 out of 6, 1 out of 6. Oh wait, there'd be no 0. It'd just be 1, 2, 3, 4, 5, 6. They'd all be 1/6. Do you know what it's called if it's just the same probability for each of them?
No.
That is called a uniform distribution.
Oh, makes sense.
I'm glad it makes sense to one of us. B.
So that's for 16, 17, 18 and 19. So would it be 1/20 and then, plus 1/20 plus 1/20 plus 1/20. And I got 1/5.
So 4/20 was it?
What, sorry?
So that's like 4/20 goes down to 1/5, is it?
Yeah.
Can you get the number 20 from this generator?
Yeah.
And so, what are the successful outcomes for 1? What numbers are successful?
16, 17, 18, 19, 20.
How many is that?
5. So 1/4.
Yeah. So that one's 5/20. And you don't have to simplify probabilities if you don't want it, because you might have to add or subtract later on, so it's good to keep a common denominator. This one's fine, same idea. That one's fine. Discrete uniform distribution. Who? Discrete uniform distribution. Okay. I think that one's all right. Okay, here we go. How do we do this stuff? Any idea?
So we have to find out the probability, and then K would be the top, but it's biased, so
let me see. I do help you. X probability big X equals wee little x. It can get 1, 2, 3, 4. What is the probability for 1?
but I don't understand how we can work that out.
It is k/x. What is
Why?
So this is like an equation that allows you to construct a table. So it's like a formula for the table.
Okay.
What is x in the first box?
1.
And so what is k/x?
Just K.
Second box?
K/2.
Mm-hmm.
And then K/3 and K/4. So that all has to add to 1.
Mm-hmm.
So would you add the k's all together?
Sure. How would you do that?
Like 1 plus a half plus a third plus a quarter k.
Kind of. I think you're kind of assuming. Okay, yeah. What would you get? K plus a half k plus a third k plus a quarter k.
25 over 12 k equals 1.
Okay. So what is
So
k?
then to get k, you would divide 1 by 25 over 12, which gives us 12 over 25, which is 0.48.
Okay. B.
So do we have to draw the symbol?
Basically, they wanted us to do that table. Why is our first table not enough for question B?
Because we need to sub in k.
Bingo.
So for 1, it's 0.48. And then for 2, 0.24. And 3, 0.16. And 4 is 0.12.
How can you check that that's correct?
If they add up to 1. Which they do.
Great. We can be sure B is correct. Question C.
So the first one is the probability of 3 and 4. So we do 0.16 plus 0.12, which gives us 0.28.
And so on. You'll be fine for the next two. They're fine. So this little beauty is, it's like a formula that gives us all the probabilities. So a 1 is k over 1. Probability of 2 is k over 2. Probability of 3 is k over 3. 4 is probability k over 4. And to figure out what k is, you would just add them up, make it equal to 1, and solve it. Any questions about that?
No.
Oops. And I just stuck that into my calculator. X plus x over 2, so I did x instead of k, equals to 1. 12 over 25. All good. Okay. How's about this?
So is the probability the same for all of the numbers here?
The probability function is the same for all the numbers.
So we sub in a 10th.
Show that you cannot use that to get it. How did they get 1 over 10?
Put it in the table and then they have to add to 1. So along the top is 1, 2, 3, and 4, and then probability of all of them is kx. Oh, so like k and then 2k, 3k and 4k. So, which is adds to 10k. So 10k equals 1. So then k equals 1 divided by 10, which is 1/10.
10k equals 1. K equals 1 over 10. That's it. Any questions there?
No.
How would you do this one?
Again, make the table.
You don't need a table.
No.
Table can help if you want to.
So no, we can just. It would be. The probability would go 1 over 15 and then
No.
1 over 15 times
No.
2.
No. You can't use 1 over 15.
Oh yeah. So probability goes k, 2k, 3k, 4k, 5k, which adds to 15. So 15k equals 1 and then k equals 1 divided by 15, which is 1 over 15.
That's it. And how many marks is that worth? It's worth 2 marks. I think you got them. Find the probability x is greater than 2. How would you go about that?
So for 3, 4 and 5, so we would sub in 3 brackets 1 over 15 plus 4 1 over 15 plus 5 1 over 15. Oops. Plus 5 1 over 15, which gives us 4 over 5.
Okay, and that's
So
I'm gonna write it as 12 over 15. That's good. Okay, any questions there?
No.
Okay, how about this thing?
So if it was in a table, the probability of 1 and 3 is kx. And then would we expand the other one? So for 2 and 4, the probability would be kx minus k. So then kx plus kx plus kx minus k plus kx minus k equals 1. So we do 1k, 3k plus plus 2k minus k.
What is 2k minus k?
Just k. so plus 1. And then for the other one, it would be so k and then 4 minus 1, so 4k minus k, so plus 3k. So 8k equals 1, so k equals 1 over 8.
1 over 8. And question B.
So when x is bigger than 1, we have 2, 3, and 4. So we sub in 1 over 8.
Yeah. Keelan, do me a favour. The probability of 2 or 3 or 4 is the same as not the probability, like the probability of not 1.
So 1 minus 1 over 8, which gives us 7 over 8.
Bingo. That's the quick, easy way. K is 1 over 8. And that, I'm sure, is the decimal equivalent of 7 over 8. Any questions there?
No.
I have to apologise. Look what the book did. The book did actually the way you were going to do it. There you go. Oh, it's tricky time. How about this?
So we have to add up all of that. So a plus 1 over 6 plus a minus 1 over 8 plus a plus 2a equals 1. So then we can do a plus a plus a plus 2a equals to 1 plus 1 over 8 minus 1 over 6, which gives us 23 over 24. So 5a equals 23 over 24. So a equals 23 over 24 divided by 5. So a equals 23 over 120.
Is that a nice easy decimal or anything?
No, it's long.
Alright. And then B.
So it wants the probability of 2 and 3. So it would be 23 over 120 minus 1 over 8 plus 23 over 120, which is 31 over 120.
23 and 31. 23, 31. And again, I just put it into the solver with x. 2 marks, 2 marks. And so this is 1 mark. That's your method mark. All the boxes they gave you added together being equal to 1. And then this is your accuracy mark for the final answer. Doesn't matter how you get there. There's only 2 marks available. Similar for the second one. To correctly substitute it in with a plus between. That's your method mark. And then that's your accuracy mark. Any questions about that?
No.
Okay. You're getting an idea of just how lazy I am. Okay, how about this tricky thing?
So the probability of it being 1 and 2 is 5 minus r.
And what is 5 minus r?
5 minus 1, which is 4, and 5 minus 2, which is 3.
Right.
That doesn't make sense.
When you sub in 1, you get 4. When you sub in 2, you get 3. So the probability that x is 1 is not 4. It's equal to the probability that x equals 4. And so if you were to sub this in, the probability that x equals 1 is equal to the probability that x equals 5 minus 1, which is 4.
If they have the same probability.
Correct.
So if we work out the probability of 1 and 2, then... Oh no, if we work out for 3 and 4, then that is the same as what it is for 1 and 2.
Not quite. 1 and 4 are the same.
So the probability of 1 is 0.28, so the probability of 4 is also 0.28. And then if the other one's equal, we can do 1 minus 0.28 minus 0.28, which gives us 0.44 divided by 2. So 0.22 is the probability for 2 and for 3.
That's it.
Okay.
B.
How can it be 7 or more if it only goes up to 4?
Twice.
Alright, okay. So then would you just have to try all the possibilities?
So what are the possibilities?
Like if it rolls on 1 both times, it'll be 0. Is it?
And so if it rolls on 1 both times, is that a successful outcome?
No. So it can only be successful if it's 3 and 4, or 4 and 4, or 4 and 3.
Very good.
So then would we do 0.22 plus 0.28?
That would be if it lands on either 3 or 4. We want the probability that it lands on both 3 and 4.
Times.
Yep.
And then add 0.28 times 0.28 plus 0.28 times 0.22, which gives us 0.2016.
2016, the year 2016. What a time to be alive. Let's see. Oh, I better check the answers. 0.216, and then this thing, and I did some stuff with my calculator. Yes, so this, let me go back. So this was just a very fancy, elegant way of them saying that the probability of 1 and 4 are the same, and you do that by subbing it in. So you sub in 1 for R, 1 for R, and you get the probability that x is 1 is equal to the probability that x is 4. That holds true for 1, holds true for 2, and so 0.28, 0.28, 1 minus that, half it to get these two, and then you can use that by listing your successful outcomes to do B. Any questions there?
No.
Very good. More of this malarkey. Let me see this thing. Okay, how about this?
So there's something wrong with it?
Mm-hmm. Any idea how you figure out what's wrong with it?
Maybe the squared?
Sub in the values for x.
So 2 over 2 squared equals a half. 2 over 3 squared. 2 over 4. It doesn't add to 1, so it can't be.
Does not add up to 1. Therefore, not a probability distribution. And question B.
Okay, so if we had a table, it would only have 2, 3, and 4, and the probability of 2 is k over 2 squared, so a quarter of k, and then k over 3 squared, so 1/4 plus 1 over 9 plus 1 over 60 equals 61 over 144k is equal to 1. So then k equals 1 divided by 61 over 144. So k equals 1 divided by 144 over 61.
And so 144, is that an easy decimal?
No, it's long.
K is 144 over 61. Okay, fine. And of course I use my calculator. Yes, part A, the sum of the probabilities is not 1. Any questions there?
Nope.
Grandiose. Okay. That stuff so far. X a half or sick.
Half.
Right. This weird time. How about this thing? Did I? Oh, find the probability distribution. Yeah.
So do we write out what it could be?
Mm-hmm.
So if it lands on red the first time, then it's just R.
Then it's just what's right? Oh,
Just
R.
R.
And so how many times? So So how many times was the spinner spun?
So
If it lands in red the first time.
once.
So S is the random variable that the number of times the spinner is spun. Okay, next possibility.
BR, so then it would be spun twice.
Mm-hmm.
And then BBR, so 3 times. And then 4 times in total.
Let me think about this. So BBR,
Mm-hmm.
and then 4 times. What would be the thing for that one?
BBBR.
That is BBBR. It's not quite, but I won't say anything yet. Okay, probabilities.
One out of 5.
Probability of getting a red is 1 out of 5.
Yeah.
Doesn't look like 1 red.
Oh, 2. 2 out of 5.
Yeah.
And then would we do 3 over 5 times 2 over 5?
Yeah.
Which is 6 over 25. Or 0.24.
Okay. This one.
And then would it be 3 over 5 times 3 over 5 times 2 over 5,
Mm-hmm.
which is 0.144. And the last one would be 0.0864.
And if you added those up, you'd be a little shy of 1. That is because there is one other possibility. The game is over when you spin it 4 times in total. What is the very final possibility of 4 spins?
That they always land on blue.
Yep. Blue, blue.
So
blue.
that would be 0.1296.
Okay. And so how do we get final probability?
What do you mean the final probability?
That it lands on, that it's spun 4 times. You gave me 2 probabilities.
Oh, so the one where they're all blue plus BBR.
BBBR.
Yeah.
So it's basically 3 over 5 cubed times 2 over 5 plus 3 over 5 to the power 4. And that's absolutely correct. I just thought you had it to hand. What's the easy way of finding the final probability?
For 4.
Yep. It will be the same as 1 minus the probability of not 4.
Yeah, okay. Which is 0.216.
1/6. And so probability of 4. Probability of 4. Probability S equals 4 equals 1 minus probability that it does not equal 4, something like that. Okay, 0.216. They wrote them as fractions. Is 0.216 the same as 27 over 125?
Yeah.
Say you sound trustworthy to me. 205, 6 over 25. And then they did 1 minus the previous ones to get that one because it's got extra stuff. This gets a bit bonkers, and so we just do 1 minus. Keep it simple. Any questions there?
No.
Exam question.
So it could be G and then P, G, and then P, P, G, and P, 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 G, and P, 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 G, and just P, 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 P. So on the top it goes 1, 2, 3, 4, 5, and then so the probability of 1 is 4 out of 7.
Yep.
Probability of 2 is 3 out of 7.
Is what, sorry? Oh, sorry. Yeah, go on. You're working
It
it out.
would be PG, so 3 out of 7 times 4 out of 7, which is 12 over 49. And then for PPG would be 3 over 7 times 3 over 7 times 4 over 7, so 36 over 343. And for 4, it would 3 over 7 times 3 over 7 times 3 over 7 times 4 over 7, so 108 over 2,401. And then if we did 1 minus all of that, I got it's not a decimal number.
Is it a fraction?
Oh no, it is a decimal number. It's not a fraction, but it's just really long. I just round it.
Just round it. I'll press answer equals.
It didn't change.
Which calculator are you using?
The same one that you have on the screen.
Chicken does, man. And you're doing it the same way that I did it?
Yeah.
What did I just do? 12 over 49. Wait. Minus 4 over 7.
Wait, you see? For 4, the probability is 108 over 2,401. Not 2,041.
2,401?
Yeah.
Oi.
Then it might work.
Yeah,
Yeah.
there we go. So just type out 2401. Okay. 2401, and so this was 81 over 2401. That's a 4 marker, and yes, 81 over 2401. Great. And any questions there?
No.
And this is kind of the beginning of binomial distribution, because you've got, like, I was doing this the short way. So that times that squared times that cubed times that, and then you could go all the way to that to the power of 4 times that. And so it would be like that's the power of 5 times the other one's power of 0. That's to the power of 4 times that's the power of 1. That's where the binomial stuff comes from. What is this thing? You think you'd be able to do this, or you want to try it?
We can try it.
Okay.
So, bias coin. Should I write out the combinations first, like last time?
If it helps, it's up to you.
So, H and then TH and TTH and TTTH or TTTT. They're both 4 times 1. So you see the probability that it says, is that just for one head?
Yep.
So then that probability is 2 over 3. So the probability of tails would be 1 over 3. So for 2 TH, then we do 2 over 3 times 1 over 3, which is 2 over 9. And then for 3, which is TTH, be 1 over 3 times 1 over 3 times 2 over 3, which is 2 over 27. And then for 4, just 1 minus 2 over 3 minus 2 over 9 minus 2 over 27, which is 1 over 27.
What was the 2 one?
2 over 9.
Yeah, that's it. And what is B?
So if it's bigger than 2, so 3 or 4, so 2 over 27 plus 1 over 27 is 1 over 9.
Okay, that's a 1 marker. 1 over 9, and those are all correct. Any questions there?
No.
This is from review exercise 1, so I just threw this in. I don't know. See, a fair coin is tossed 4 times, an equal number of heads. All the outcomes are the same. The first tail occurs in the third throw. So that is, I think, probably better to do when you've done binomial. That's the answer. Review exercise. So this is very similar. Construct a table based on this malarkey. Confident in that, or you want to do it? I think you'll be able to do it.
Sure.
I think if you do it, you'll get it right. Just like with this one, the heads one, I thought if she does this, she'll get it right. And I didn't help you at all, and you got it. Another review exercise thing. So you snacked me many weeks ago you told me, can we do one more question that's kind of similar to what we just did, and I didn't have one. So now I'm going through the entire book, including the review exercises, including the mixed exercises, to make sure I find every single one of these exam questions. Unfortunately, when I look at the new spec and look at the past papers for the new spec, I'll find like one exam question, and so that's not very helpful. Fair things, poor time, make a table. Oh, hang on, state the distribution of x. What is this one?
Discrete, uniform.
Yep, discrete, uniform. I'm going to just stick distribution at the end.
Do you have to say that?
That's what it said the last time.
Okay.
The spinner is spun 4 times. The number of spins, odd number is recorded. Make a table. Okay. Hold the phone. Is this the right answer? 18. A, B, C. Y is greater than 2. Y is greater than 2. What? State the distribution of x. The probability of x is 0.2. Bookie. That seems terrible to me. That seems wrong. Oh, that's... State the distribution of x. Maybe if they say the type of distribution, you'd say discrete uniform distribution. In this case, probably.
Yeah.
Why would they snag this, man? Okay, that stuff. X, a half, or a tick.
A half.
So that is 35 out of approximately 100 and something. So that's about a third of that chapter. But we did it very, very thoroughly. The stuff after that is binomial and stuff. That stuff will entirely go in the calculator, but you may not know how to do it in your calculator. Do you know how to find binomial stuff in your calculator?
Maybe, I can't really remember.
We may never have done it. So menu distribution is 7.
Okay.
We want binomial probability distribution, so that's 4. Let's go with variable. And what are the values for this one, do you think?
For x, is it 2 for A? And then N and P 12 and a 6.
Yep.
Is it that way around?
Yep. So x is binomially distributed. And then you get 29.6%, let's say.
Yeah.
0.296. What would be B?
X is 9. And then the other two are the same.
Yep. Oh wow. So you've got 5 zeros and then 126. So a very tiny number. Or if you multiply it by 100, you'll get a percent. So 0.00126%. How would you do C?
Do you still put X as 1?
They wanted that x is less than or equal to 1. So if it was equal to 1, you'd put in 1. That would be your answer. How would you deal with x is less than or equal to 1? And x can't be a negative number. This is like number of times it lands on heads or something.
Oh, it's just 0 or 1.
And so how would you go about that?
Would you have to do it twice?
So one way is you would do it twice and you would add the two together.
Yeah.
The other way is you would do menu distribution instead of 4 for binomial probability distribution. You'd press down and go to binomial cumulative distribution. Variable x is 1. It's the same thing. X is 1, n is 12, p is a sixth, and it automatically does the probability of 0 plus the probability of 1. So they did them separately, and they got 0.381 altogether. That way, 0.381, that one. So that's cumulative distribution. The other are probability distribution, and that should give you a way into the second part of that chapter. Any questions about that one, Keelan?
No.
Well done. Anything in particular you want to do next time? If you want, we can continue this chapter or something else.
I think probably just this chapter, please.
Okay. And do you get work from your school or something? Is that how it works?
Yeah, but not now because it's Easter holidays now.
Okay. Any questions for me in general?
No.
All right. Well done, Keelan. You did wonderfully. And I look forward to talking again next week.
Thank you. You too. Have a good week.
You too. Goodbye.
Bye.